many of you are familiar with computer vision stuff? Like 1, 2, 3, 1, okay? So because the thing is, computer vision is it's interesting and it's kind of easy because there are a lot of tools already made for you. So you can easily like just come up with something and make it work fairly fast. So I'm gonna show you how to do easy face recognition thing with your Ci20. Did you ever try to do anything like that? Like just with your camera recognize your face or something like that? No. Okay. So I have the Ci20 plugged to my computer, and this is the camera. So I plugged it via USB.
We've got a lot of those cameras as well available.
Yeah,
So.
yeah. And then I'm gonna try to do it in Python. So it's really 10 lines. So I'm gonna try that in front of you. It's gonna be a bit difficult because I have to. But so how many of you do not know Python? Okay, good. No, that's good because I also don't know it. So, but it's very easy, as you will see. So, all of your boards already have OpenCV installed. OpenCV is a standard library to do like computer vision things. It does a lot of things already embedded. So, how does it work? So, how does it work in general? Like, how it works is. Okay, I'm gonna explain it and then I'm gonna show you because of what I can type. So how it works is when you want to recognize an object, you usually, like one of the standard approaches, especially with faces, is using a neural network. So a neural network is just a tool that allows you to, that can be trained and gather some knowledge that then you can reuse easily. So like for example, in terms of for recognizing an object, you're just gonna push a lot of images of the same object, like a cat, from many different perspectives and say, this is a picture with a cat, it's a picture with a cat, it's a picture with no cat. And the neural network is going to get the difference between it and basically infer the decision boundary so that in the future you can say, okay, this image, where does it lie? Does it lie in the space of cats or the space of no cats? And this is going to happen, what's going to happen with the faces also. So this is how the computer vision, like OpenCV does it too. And so basically, the main things that you have to do is import already trained neural network to recognize your object. Because training one yourself will take you like probably a week, maybe more. So there are many available online. So you just import it, and then you are basically ready to do the recognition. So this is everything you need. So as you see, like, so this is where you load your classifier, which is your knowledge, like the output of neural network, just as a file you can find online. And then this is where you start. You get a stream from the camera. 0 just says give me any camera that is connected. So then you can enter just a while loop, and then you constantly get a frame from the stream. You convert it to grayscale because the standard way to do face recognition with the most standard algorithms use features that are in black and white. So you just in grayscale, so you convert it to grayscale, and then you just call this detect multiscale method on the detector that you created before. So it has a few parameters, like there is a scale factor. Well, this kind of influences your performance. So if you put it higher, it will just go faster, but it will be less precise. This regulates minimum size is the minimum size of the face that you can recognize. It's in pixels of the image. And the last flag, there's a last flag. So it's just really an optimization. Yeah, it's just an optimization that you can do, and it will work without it. So you get a faces array in which you're gonna have the rectangles of your faces, if any, were there. So then you can just check whether there were any faces in the array, and then print whatever, or do whatever magic you want to do when you have a face. And well, you can. This is useful. Like you want to just write down your frame, you can use this I am bright, and just give it your frame object, like the tab, and the frame that you read. So this is how you do it most of the time. There is one problem. So what I try to do it now with the CR20, and I think the cameras that we have are not really working properly with drivers. So what happens is that after you get a frame, after the first frame, the next frames are might be kind of messed up. So the easiest thing to just make it work is put everything in the loop. I'm gonna share this code with you afterwards, so you can just read it again. So put everything in the loop. It's not really efficient because you're gonna recreate the camera stream every time, but it makes it work. So yeah, so I can actually run it. So let's see. So that should be it. If I just let's see if it works with my face. My face is not good. So it's going to print either. Okay, so it's going to say no, and then if I point it to myself, maybe it's going to say yes. Let's say yes. Never works in real.
Yes.
Yes.
Woo.
So now if I point it to the floor, it should start saying no again. Yeah. Let's see if it works with you.
Nope, no face.
Wait.
Yes.
Point it to- Okay, it has a few frames of the delay, which is annoying. So if you use it, you can do things like if 3 frames in a row were a face, then do something. So because otherwise you get some noise. Or you can play with the parameters, like the number of neighbors. If you decrease it, you're gonna get more positive results, but also more false positives. So yeah, that's exactly. So it's very easy. So this explains. I think it's a demonstration of like the tools today are so advanced that with very few lines you can really do something. And of course, at Imagination we try to build over those tools. So maybe in 24 hours you're going to do much more than this. So let's see.
Thanks. Okay.